In this video I'll be using the new Automated Rose Ornamental Lathe to design and print out some rosette patterns on index cards and then carve out the resulting patterns on laminated wood blocks. For the printing of the design patterns, I'll be using rosettes which I've designed and 3D printed, and also the new aluminum flat plate chuck and a new felt tip pen holder which were described in the previous video. I'll be cutting out the design patterns on laminated wood blocks. I use my Accu-Slice system to cut some thin layers of contrasting woods. These wood layers vary in thickness between 20,000 of an inch and 50,000 of an inch thick. Between 3 and 5 of these laminates were then glued onto the surfaces of some 3-inch diameter MDF wood blocks. Each of these layers was glued together using Titebond 3 type glue. When the design patterns are cut into the surfaces of these laminated boards, the contrasting layers will make these design patterns more visible and enhance their appearance. I needed an easier and more accurate method of adjusting the position of the pen against the paper. This was especially critical since I'm using felt tip pens, and if there's too much pressure, the pen tip will crush. If there's not enough pressure, the pen will not record on the index card. I modified the Rose Machine software in 2 different sections. On the screen for setting up the X and Z positions, I added software to accurately adjust the home positions. In the past, I just used the linear move buttons to move the X and Z stepper motors. While this method may work for large movements of the stepper motors, it was quite hard to move them in very small increments. Therefore, I added software to move both the X and the Z motors in increments as small as thousandths of an inch. For example, to move the pen position inwards towards you or towards the paper, you first type in the amount you want to move the pen. This is the default value, but you can change this to anything you want. After setting the distance you want to move the pen, you then push the move button to move the motor that amount. The stepper motor advances that amount and records this value on the screen. You can keep pressing the move button to continue to move the pen some additional amounts. And then you can keep pressing the move button until the pen is correctly positioned against the paper and the value is recorded on the screen. Then you press the set home position. This becomes a new home position and the value is recorded now as 0 on the screen. And this home position will be used for all future movements of the pen. I also added the ability to adjust the X positions in the same manner. This enables the accurate positioning of the pen in the center of the spindle, or to make other adjustments as needed. I also added additional micro adjustments to the screen to print the patterns on the index cards. If you need to do a minor adjustment of the pen location, or if you prefer, you can just go back to the XZ Home setup screen. However, to make it easier and more convenient, I added several additional buttons to the pattern printing screen. By pressing the left or right buttons, you can move the pen position by 1/1000th of an inch. You can move the pen either left or right until it is accurately positioned. Note the total amount that you have moved the pen is shown on the screen. Then you press the set button and the new home position is set and the screen will read 0. It's important that when you make these adjustments, the pen is against the paper and not in the initiating position. Previously, I've written a program to enable the repositioning of the pen 1/2 inch away from the surface of the paper. This feature was added to move the pen away from the flat plate chuck to enable the attachment of the index card to the headstock plate. However, in order to move the pen back against the paper to the Z0 position, I added the additional Move to 0 button to reposition the pen back against the paper. You can then use these 2 buttons to move the pen back and forth between the home position and initiating position. Pressing either of these buttons to move a second time will not move the pen any additional amount. This prevents any error that could possibly occur by moving the pen twice. I'll be going through the steps to set up and align the felt tip pen to begin the process of printing a design pattern on an index card. The first step is to adjust the felt tip pen height to be on center with the center height of the spindle. This is important to get accurate shapes from the rosette patterns during printing. If the pen is either too high or too low from center, you will get tilted or non-symmetrical patterns during the printing process. On the flat plate chuck that I machined, I had etched 2 intersecting lines that mark the center of the spindle. I used these lines to adjust the height of the pen. I then used the adjustment knob on the pen holder to adjust the felt tip pen height to line up with these etched lines on a flat plate chuck, and then I locked the pen holder in place. Next, I want to verify that the felt tip pin is exactly on center. I go to the XZ program, which will enable the movement of the X and Z stepper motors. I then attach an index card onto the flat plate chuck and move the felt tip pin against the index card. I next move the X stepper motor back and forth to create a horizontal line on the index card. I then go to the spindle adjustment program and using the bottom program, I enter a rotation distance of 180 degrees and press the clockwise button to rotate the spindle to 180 degrees. I then go back to the XZ program and once again move the X stepper motor back and forth horizontally. If the pen height is exactly on center, the two lines should be precisely aligned, one on top of the other. If not, the pen height will need to be readjusted. After removing the index card, attaching a new blank index card onto the flat plate chuck, setting the pen height, and adjusting the pen position to accurately print on the index card, I'm now ready to print patterns on index cards. I'm using an 18 pattern sine wave rosette for this program. I select the Print Patterns on Index Cards program. I've already programmed in 5 patterns for this first printing. Each of the patterns is spaced a 1/4 inch apart from one another. Later I will generate a second pattern to generate a second group of patterns spaced 1/8 of an inch between each of these patterns, in which I will change the phase of the rosette by 1/2 of the sine wave. My spindle speed is set to 1 revolution per minute, and when I'm ready to print, I press the Start Run program. I sped up this section of the video 10 times the actual printing speed to reduce your viewing time. Notice that as each pattern is being printed, the heading color for that section of the program changes to a red color. This feature is nice because it tells you which step of the program you're actually printing. After the first set of patterns has been completed, I added 0.125 inches to each of the pattern distances. I also changed the phase of the rosettes by 1/2 of a sine wave. When complete, I once again press the Start Run program. The program now prints patterns between each of the previous patterns. By adjusting the position of each of these patterns by 0.125 inch and adjusting the phase of the rosette, a unique pattern is created in which the alternating phase patterns just touch one another, and the final design looks like complete circles merging in the center of the spindle. This is the reason I like to generate these patterns on index cards before I actually cut them out on my wood samples. It's just much faster, especially if I need to make any changes in the dimensions of the spacing. This can be most easily done using these printed patterns. This is the finished design pattern, and now I'm ready to cut this pattern out on some laminated wood blocks. For the cutting of the rosette patterns on the face of the laminated board, I select the program Face Rosette Patterns from the main screen. This screen looks much like the previous screen for the printing of the patterns. I entered the same values for the radius patterns that I previously used for the printing program. However, I added some additional values for the total depth of the cuts and the depth increments. Cutting the total depth in one pass may overload the spindle motor and might also cause undue splitting or burning of the wood. I get smoother cuts by taking multiple, shallower cuts. Before I'm ready to start cutting, I first of all align the tip of the cutting tool against the face of the laminated wood block. I use the same procedures that I used previously to set the pen position. What I'm using here is a small piece of paper to help adjust the cutter position. I move the cutter in until it just catches the paper. I then move the cutter in an additional 4/1000 of an inch, which is the thickness of the paper, and then I press the Set or Home position to set this distance for the program. Before I start, I then press the Initialize button on the screen to move the cutter 1/2 inch away from the board surface. For this cutting operation, I'm using a 3-inch diameter MDF board with multiple layers of contrasting woods. As I cut through the various layers, the underlayers of the contrasting woods will make the design pattern more visible. I then press the Start Run button on the bottom of the screen. I'm using a 1/4 inch diameter by 60-degree pointed cutter tool, and I'm operating the cutter at 10,000 RPM. To reduce your viewing time, I have sped up this video 10 times the actual cutting speed, and I'm heavily editing the footage to reduce your viewing time. The cutter makes multiple passes for each pattern. For each revolution of the spindle, the cutter moves in 10,000 of an inch until the final depth of 40,000 of an inch is achieved. In other words, it takes 4 passes of the cutter to achieve the total cutting depth of 40,000 of an inch for each of the patterns. And here you can see the cutters reach the second layer of the laminated board, so the pattern is coming up as a darker color. After the first pattern is complete, the cutter moves to the second pattern position and continues to cut the pattern until the last pattern is complete. The pattern title on the screen changes to red so you know exactly where you're cutting. Here I'm just jumping to the final pattern. On the smaller inner layers, I usually change the depth to a shallower depth. When complete, I increase the radius values for each of the patterns by 1/8 of an inch, as was done for the printing program. I then change the phase of the rosette by 1/2 of a sine wave. I then press the start button to start the cutting of these patterns. Once again, these patterns are being cut between the previous patterns. As additional patterns are cut, the desired pattern of circles become apparent. The underlayers of contrasting woods make these pattern cuts more visible. And here is the completed project. I also cut a second project using the same program, but cutting the pattern 0.70 of an inch deep into the top surface of the laminated board. This gives a much deeper impression of the pattern, and I actually like this much better than the previous one. I changed the rosette to generate a project with a different shape. This pattern is similar to a two-door pattern. I'm using a new 0.20 inch diameter rubber for this rosette, since the V-shaped recesses are quite sharp on this rosette. This will assure accurate tracing of the rosette pattern. I generated a pattern with the spacing of the pattern in sets of 2, each of them 1/10 of an inch apart, and then the sets 3/10 of an inch apart. I then printed out the pattern as was described previously, and here is the resulting pattern. I cut this pattern 0.90 of an inch deep for this project. This took quite a bit longer since this project required 9 passes of the cutter to achieve the desired pattern depth. And here is the finished project. Notice how clean and crisp the cuts are in this sample. I next created a project using a 10 sine wave rosette. This project is similar to the first project. The first project used an 18 sine wave rosette, and this rosette has 10 sine waves. The amplitude of the sine wave is also larger for this rosette, and this required a spacing of the patterns by 0.5 inches. I also used a second pattern for this project with phased patterns between each of the first set of printed patterns. And here is the final pattern for this project. Once again, I cut the pattern on a laminated board. Each of the patterns was cut to a depth of 0.40 of an inch, with the exception of the innermost pattern, which is only cut to a depth of 0.20 of an inch. And here is the resulting cut project. For this final project for this video, I used the same program using the 10 sine wave rosette as we just described for the previous project. However, for this project, I wanted to cut the pattern very deep to see what kind of contour patterns I could create. The total depth for each of the patterns was set to 100,000 of an inch, or 0.1 inches. Since the project required 10 passes on the cutting tool for each of the patterns, it took over an hour for this project to complete. I used a solid block of walnut wood for this project, so I'm not getting the multi-layer contoured effect that I demonstrated in the previous examples. This project also demonstrated the results of cutting down 0.1 of an inch with each step and also operating the 60-degree pointed cutting tool at 10,000 RPM. All of the cuts turned out quite smooth, with no burn marks, no burrs, or no splinters on any of the cut surfaces. Here is the finished project. The cuts on the surface are very clean, and the depth of the cuts creates a unique contoured pattern. One idea that I'll probably do in the future is to cut the outer patterns much deeper than the inner patterns. This would create a unique pattern on the board surface. These are the design patterns that were cut on laminated and wood blocks for this video. Here are a few other examples of some designs I produced using this new Automated Rose Ornamental Lathe. On several of these designs, I used 2 or more rosettes to produce some more intricate patterns. There will be many more examples in the future. The one thing I did not do in this video is to use 2 or more different rosettes for the same project. This would create a wider variety of unique and complex patterns. I currently have over 30 different rosette patterns in my inventory of rosettes. This is why I do the initial design by printing out the patterns on index cards. You can then try different spacing of the patterns, use multiple rosettes, and change the phasing of the patterns. The design capability using these rosettes with different parameters is infinite. I currently have about 40 printed cards for designs that I use to select patterns for my future projects, and I will continue to produce additional patterns in the future. Thank you for watching this video. If you have any questions or suggestions on how I can improve the Automated Rose Ornamental Lathe, please leave your comments in the comment section below or send me an email. And thank you.